Another proportion problem, and in my other video I did a proportion problem as well. So this is my second proportion problem. Anyhow, basically, in the other proportion problem, we did an increase problem, and basically what we were doing is we were trying to figure out the price of a postage stamp before it increased. And even though it seemed like in that other problem, if you go back and look at it, that we were going to decrease, we weren't actually decreasing. We were doing an increase problem, an increased proportion problem, and in this problem, it's going to look like we're going to be increasing because we're looking at his weight before, right? We're looking at his weight before he lost 5% of his weight. So he's actually going to weigh more in the end. So it looks, we think, okay, he's going to be increasing his weight. Well, we're not increasing his weight. That's not what we're doing. We're actually finding what his weight used to be before he lost the weight, all right? So basically, he started out as, a certain amount of X, right? He started out as X, I guess, and he lost Y, okay, and in the end, he weighed 171 pounds, okay? Well, that X represented 100% of his weight before, okay? So that's what he weighed before, when he lost 5% of his weight. So basically, he now weighs 95% of his past weight, okay? So even though you might read this problem and think initially that it's increase, it's not. It's actually decrease. And just like the last problem, I set it up the same way. It looked initially like it was a decrease, but it wasn't. It was an increase, okay? And all we're trying to figure out is what he weighed before. Just like in the last problem, we're just trying to figure out what the postage stamp cost before, okay? So anyway, let's set this up. Let's go ahead and erase this. There we go. So we'll make this quick and easy. This one's pretty simple, just like the last one was simple. So let's see here. Let's get a color that we need. Let's go ahead and use yellow. So let's see here, 171 pounds. Okay, so that's what he currently weighs. All right, and in a proportion, you have something over here to the left and something over here to the right. Oops, let's cancel that. You have something here to the left, to the right, and something here to the left, and you have something like this, okay, and then you have an X. All right, so 5%. All right, we just kind of went over that. He was 100%, right, and he lost 5% of his weight, and that 5% of the weight is 95%, right? And his current weight therefore represents 95%, so we put a 95 here and 100 here, and then we put an X down here. All right, so it's set up the same way as the last problem. Same way as the last problem, but instead of an increase problem, this is actually a decrease problem, okay? So anyhow, what we need to do is we need to solve for this x. So how can we do that? Well, we can do cross multiplication if we feel like it, and let's just do that. Let's do cross multiplication. So we're going to take this number right here, 95, and we're going to times it by this x right here. And we're going to take this 100, and we're going to times it by the 171, okay? All right, so I just told you in the last video that you take 100, and when you times it by something, you're just basically adding zeros. If it's a whole number, you're shifting over, there's a decimal here. There's a decimal you don't see, all right? And let's see here. You don't see this decimal here, normally. And basically, there's a decimal at the end of this number. Well, you're going to shift that over 1 and 2. So now the decimal is going to be here, and these two places are now going to be filled with zeros. That's why you can add just zeros. You can just add zeros to a whole number, or pretty much any number when you times by 100, or if you times by 10, you add 1 0. If you times by 1,000, you add 3 zeros. Anyhow, let's go ahead and write this out. So 95x equals 171 with 2 zeros, so it's actually it's actually 17,100. And then we're just going to do long division. So let's go ahead and do long division. Let's use another, let's use a different color than that. It's kind of fun to use different colors. So let's go ahead and use 95, all right, into 17100. How many times does 95 go into 1? Doesn't. How many times does 95 go into 17? It doesn't. Does it go into this number? Yes, it does. How many times? Well, I'd say it goes into it one time. So one time, put 95 here. Oops. It didn't like that. Let's try that again. There we go. 95 here. Now, 5 minus 1, you can't do that, so you cross that out and make that a 6. All right. And then add a 1 here. Now it's 11, so now it's 11 minus 5, which is 6. Okay. And then you take this 16 now, because it's a 1 and a 6, 16, and you minus 9 from that, so it's going to be 76. Okay. Like so. And then we're going to add a 0 right here. All right. Oops. That's an ugly 7. Let's try that again. All right. And then the next question at hand is how many times does 95 go into 760? Well, I already done this before, so I know it's 8, and I'm just going to stop there because 8 times 95 is this. So it's 0, and then bring down another 0. How many times does 95 go into 0? Well, that's 0. So basically x equals 180. That's how much weight he weighed before, 180 pounds. All right, well, that's pretty much it. I'll end there, and I hope you enjoyed the video.